Mic problem unna.
Pushpa earphones తీసే నార్మల్ గా.
As I have presented the finite automata example, in this finite automata, I am going to act as an initial state, which is called Q naught. When I give in this finite automata, I am going to consider the inputs as we have seen the 0 or 1 as black pen and blue pen. In this finite automata, when initial state gives an input 1 to the state Q1, Q0, it will reach us to the state Q1. When we give the input 0 to the state Q0, it will reach to the trap state. As we all know that we have trap state in finite automata. One of our friends will continue the remaining.
Pushpa, please present the screen.
Is my screen visible?
Yeah, it's visible.
Mahalakshmi, continue.
Pushpa, please present the PDF. PDF is not visible, Pushpa. Okay, it's clear. Okay. Here in this automata, hello everyone, I am Mahalakshmi. Here in this automata, I am acting as Q2 state, that is intermediate state Q1. Q1 on input 1, it goes to input 1, it goes to trap state or death state. On input 0, it goes to Q2, that is final state, which is explained by Pratyusha. Thank you.
Hi guys, I am Pratyusha. Here I am acting as a Q2, which is final state having a self loop on 0, 1. That means on input 0, that is in black pen, I am in the same state, and input 1, I am in the same state. That means since I have the self loop on 0, 1. Before constructing the regular expression for this finite automata, we have the basic knowledge on the regular expression operators which are used. We use star, dot, and plus operators in the regular expressions. For representation of OR operations, we use plus operator. Here, in the given finite automata, at Q2, getting an input 0 or 1, it goes to the same state. Here we use OR operations. So, for 0 and 1, we use plus operator here in the regular expression. And dot operator is used for if one symbol must be followed by another symbol. Let us consider the given finite automata. Q0 on input 1, it goes to Q1. Q1 on input 0, it goes to Q2. That means 1 must be followed by 0, then only it reaches the final state. We use dot operator for this purpose, and also star operator representation of self loop in finite automata. We use star operator. Here star means repeat any number of times. See, at Q2, 0 and 1 are repeated any number of times. It can be accepted by this finite automata. So we use star operator here. Next is control continued by one of our friend.
So, after analyzing the finite automata with all possible input symbols, we clearly understand that finite automata can accept only strings those which starts with 1 0 and ends with any combination of input symbols or 0 or 1. Regular expression was proceeded by PUSHPA.
And the next one is the regular construction of an regular expression. In this finite automata, we can say that the inputs are followed by sequentially. That means the representation of regular expression must be in the starting state to initial ending state. In this way, when we consider the finite automata, the obtained regular expression of the finite automata is 1 0 and 1 plus 0 whole star. And the next one, the language accepted with the regular expression will explain by our friend.
This is the language accepted by the regular expression is 101, 100, 100, 1011. It starts with 10 and ends with any one alphabets 0 or 1. For better understanding, one of our friend explained some examples for this regular expression. I pass on the mic to the Pushpa.
Let us consider an example to show that regular expression which we are obtained from the finite automata is correct or not. In this process, I am going to consider the first string which was 101. As we consider the string which is 101, as I have already explained that inputs we are going to consider as 0 or 1, which is black pen or blue pen. In this process, first when we consider the initial state as q naught, when we give the input 1 to the q naught, it will goes to where input 1 means the blue pen, which is input 1, and when we give the input 1 to the initial state, it will reach to the state q1, and then after that when we give the input 0 to the q1, it will reach input 0 to the q1, it will reach us to the q2. After that, we have also seen that self looped. It means when we give either 0 or 1, 0 or 1, it will reach us to the same state. For in this process, when we give the input 1 to the Q2, it will be in the same state. Next example will be explained by our friend Mahalakshmi.
Next example is our string. We consider the string 1000. On input 1 starts with the q0, and input 1 it goes to q1. On input 0 it goes to q2. On input 0 it present at the same state q2. On input 0 it present at the same state q2. Here it reaches to the final state q2. So this string is accepted by this given finite automata. Next will continued by Maha.
Till now, we have seen strings, those which are part of this language and accepted by this finite automata. But what if we take the strings which are not part of this finite language? What happens in a finite automata? Let us consider a string 110. Now Q naught on 1, that means blue pen. Q naught on 1 goes to Q1. Then Q1 on 1, it goes to trap state. That means it does after the completion of string. After the completion of string, we are unable to reach the final state. So we are going to trap state. That means this language is this string is not accepted by this finite automata. This is about the regular expressions and the types.
In this
Thank you so much.
presentation, we have seen the construction of a regular expression as well as the language produced by the regular expression is accepted by the finite automata or not. This is the overall view of a regular expression. Thank you.